Good day, viewers. Welcome to today's class. I'm Chioma, your mathematics teacher. So today we're going to be taking some examples under logarithm. In our last class, we did examples under logarithm, but today is going to be a different thing, still on logarithm, but we're going to be looking at equation involving logarithm. Equation involving logarithm. So we have equation involving logarithm. Okay, so we are going to be taking some examples under equation involving logarithm. All right, so we have example one. Okay, so first of all, solve for the unknown in the following logarithm questions. Okay, so solve for the unknown. Anytime you hear the word equation, just know that there is unknown for you to look for. Okay, so we have example one. Example one says solve log x base 10 is equals to what? 4. Log x base 10 is equals to what? 4. Just like we say solve for the unknown. The unknown here is x. So we are going to look for what? X. If you are asked to find log x base 10 equals to 4, the unknown here is x. So we are looking for x. So x will be equals to what? 10 raised to the power of 4. Just know that anytime you are having unknown in a logarithm equation, the logarithm itself is equals to the base raised to the power of the answer. Now, it doesn't really matter whether the logarithm is the unknown or the base is the unknown or the answer is the unknown. Wherever the unknown is appearing, you follow the same procedure. Okay? So, of course, we are going to solve different examples where we will have the logarithm as the unknown, we also have the base as the unknown, and we also have the answer as the unknown. We'll solve examples like that. So, just know that the procedure is the same thing. Your logarithm will be equals to the base raised to the power of your what? Your answer. So if we are solving this will give us x is equals to what? 10, which is the base, raised to the power of what? 4, which is the answer. So how do we get our x? X is equals to 10 raised to the power of 4 means 10 times 10 times 10 times 10. Okay? 10 times 10 times 10 times 10. That's multiply 10 into 4 places. Okay, so how do we get our x? 10 times 10 is what? 100. 100 times 10 is what? 1000. 1000 times 10 is what? 10,000. So s is what? 10,000. Yes. So our x is equals to 10,000. That's our final answer. So let's just go through it one more time. It says solve log x base 10 equals to 4. I said anytime you are dealing with equation involving logarithm, just know the procedure. It doesn't matter whether the logarithm is the unknown or the answer is the unknown or the base is the unknown. Just follow the procedure. That the logarithm itself will be equals to the base raised to the power of the answer, which is 4. And that's exactly what we have here. Log x, that's x you are saying here, is equals to the base, which is 10, raised to the power of the answer, which is what? 4. Okay, so if we have x is equals to 10 raised to the power of 4, 10 raised to the power of 4 means multiply 10 into 4 places, and that's 10 times 10 times 10 times 10. And when you multiply it, you will have what? 10,000. So our x is equals to what? 10,000. So log 10,000 base 10 is equals to 4. All right, so that's that for example 1. Now let's take example 2. Example 2. Example 2 says log x base 2 is equals to what? Minus 6. Log s base 2 is equals to what? Minus 6. Just like what we did in example 1. Okay, now the unknown is also the logarithm. So this one is a bit simple as well. So you have your x will be equals to the base, which is what? 2. You write your 2 raised to the power of the answer, which is what? Minus 6. The logarithm is x equals to the base, which is 2, raised to the power of the answer, which is minus 6. Now, you remember when we're dealing with indices, this is what we call inverse law. When a number is raised to the power of a negative number, it simply means the inverse of what that number is. So this is going to give us x will be equals to, this minus will turn to 1 over 2 raised to the power of 6. 1 over 2 raised to the power of 6. So what do we mean by 2 raised to the power of 6? It means 2 times 2 times 2 into 6 places. And that will give us equals to 1 over 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Okay, so we can put the 1 at the middle here. So we'll multiply 2 times 2 times 2 times 2 times 2 times 2 into 6 places. Okay. So let's multiply that. 2 times 2 will give us 4. 4 times 2 will give us 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 will give us 64. So our final answer, x, is equals to 1 over what? 64. That's the answer for example 2. Okay, let's go through it one more time. It said log x base 2 is equals to minus 6. Like I said, follow the same procedure. Your logarithm will be equals to the base raised to the power of the answer. That's the rule. Or should I say that's the method you follow. Okay, so this is our x you are seeing here. Our base is 2, so you write down the 2 raised to the power of our answer, which is minus 6. Now, because of this minus, we need to remove this minus. And for us to remove this minus, we are going to be having inverse, which is 1 over. So that minus has turned to what? 1 over 2 raised to the power of 6. And 2 raised to the power of 6 means multiply 2 into 6 places. That is what we have here. And when you multiply that, you have what? 64. So our x is equals to 1 over 64. So this 1 over is appearing because of this minus. Assuming there is no minus here, we will just get our answer, x equals to 64. Okay, so take note of that. Anytime you have a negative answer as your power, just know that it will be 1 over your final answer. All right, so that's that for example 2. Let's take another example, a different one now. Let's say example 3. Okay, so this example 3 says log x, no, sorry, log 81 base x is equals to 4. Log 81 base x is equals to 4. So you can see that in this example 3 is a bit different from example 1 and 2. What's the difference? Now the unknown is appearing as the base, not the logarithm this time around. If you check example 1 and example 2, the unknown was appearing as the logarithm. But in this case, the unknown is the base. Okay, so that's why I said I'll give you different examples so that any question you see, you should be able to know how to solve it. Okay, so in as much as our unknown is appearing as the base, we'll follow the same procedure. And the procedure is the logarithm will be equal to the base raised to the power of the answer. So what's our logarithm? 81. So we have 81 will be equals to what's our base? X. Say x raised to the power of what's our answer? 4. Are you seeing it now? So we have 81, which is our logarithm, is equals to the base, which is x, raised to the power of the answer, which is 4. Okay, now if we have something like this, how do we get our answer? Remember, we are looking for the unknown, which is x. Now, for you to get the value of this x, we are going to, since x is having a power 4, we are going to change this 81. We are going to write the index form of this 81. That's, we'll look for a number that will be raised to 4 to give us 81, since x is raised to the power of 4. So what's that number? We'll not ask ourselves. It's just like finding the fourth root of 81. What is that number that will multiply itself 4 times to give you 81? And that number is 3. Let's try it. 3 times 3 times 3 times 3. Let's check. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 will give you what? 81. So we are replacing this 81 with the index form of it, and that will give us 3 raised to the power of 4. So 81 has turned to 3 raised to the power of 4. So we write equal to what? X raised to the power of 4. Now check very well, something is happening here. We are having raised to the power of 4 here. We are having raised to the power of 4 here. Now you remember when I told you during indices that when the two powers are the same, you equate base. When the two bases are the same, you equate power. So in this case, since we have succeeded in making this 81, 3 raised to the power of 4, and our s is raised to the power of 4, since the two 4 are the powers, what you do here, you say what? Equate base, because the two powers are the same. So if the two powers are the same, you say what? Equate base. And what is our base? 3 and x. And remember, this is the base we are looking for, which is what? X. So you say x or 3 is equals to x, or x is equals to 3. It means the same thing. If you say 3 is equals to x, it also means that s is equals to 3. So our final answer, s is equals to 3. Okay, let's just go through it one more time. I said, if the unknown is appearing as the logarithm, or is appearing as the base, or is appearing as the answer, you follow the same method. Okay? So in this particular question, which is example 3, the unknown is appearing as the base. Now we have log 81 base x is equals to 4. We follow the same procedure. So we have that 81 will be equals to our base, which is x, raised to the power of the answer, which is 4. So 81 is equals to s raised to the power of 4. Now, if you find yourself in this situation, what do? The aim is for us to make the two numbers to have the same power so that we can equate base. Okay, and how do you do that? Since s is raised to the power of 4, you now look for a number that will be raised to the power of 4 to give you 81, and that number is 3. Okay, so you check 3 multiply itself into 4 places. Will it give us 81? Yes, that's what we did here. 3 times 3 times 3 times 3 into 4 places will give us 81. So we now replace 81 with the index form, which is what? 3 raised to the power of 4. So we now have 3 raised to the power of 4 is equals to s raised to the power of 4. Once you are here, so long as the two powers are exactly the same number, all you just need to do is equate your base. This is the base. 3 and x are called the base. These 4 and 4 are called the powers. So if the powers are exactly the same thing, you equate base. And when we equate base, we have that 3 is equals to x. And if 3 is equals to x is also equal to 3. They mean the same thing. So that is that for example 3. Okay, let's take example 4. Okay, example 4. Say log 32 base x is equals to 5. Log 32 base x is equals to 5. Okay, so this is just like what we just solved now. Log 32 base x is equals to 5. So just like what I said, in any of them, you follow the same method. So what we are going to write next is that 32 will be equals to x raised to the power of 5. Yes. So our 32 is equals to this x, which is the base, raised to the power of this 5, which is the answer. All right. So like what we did in example 3, we looked for a number that can multiply itself 4 times to give us 81. I'm referring to example 3. So now we are now in example 4 and we are having another number 32. Now this is s raised to the power of 5. What number can multiply itself 5 times to give us 32? Because that's the only way we can have the same power. The two will not have the same power. So we ask yourself, what is that number that can that can multiply itself 5 times to give us 32? And that number is 2. Let's try it. 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. Okay, so we are having 5 now. So let's multiply. 2 times 2 is what? 4. 4 times 2 is 8. 8 times 2 is what? 16. 16 times 2 is 32. So now we are replacing 32 with 2 raised to the power of 5. That's the index form of it. So we have 2 raised to the power of 5 is equals to what? X raised to the power of 5. So the 2 is now having raised to the power of 5 raised to the power of 5. And if that happens, you do what? You equate base. Say equate what? Base. So this is raised to the power of 5, this is raised to the power of 5. The two powers are the same. You equate the base. So here you say 2 is equals to x, or you say x is equals to 2. 2 equals to s equals to 2, they mean the same thing. Okay, let's just go through it one more time. Say log 32 base s is equals to 5. Your 32 is equals to the 5, which is, your x, which is the base, raised to the power of 5. And you look for a number that will multiply itself 5 times to give you 32. And that number is what? 2, just like what we did here. So 2 multiplying itself 5 times will give us what? 32. So you now replace this 32 with 2 raised to the power of 5. And that will give us equal to what? S raised to the power of 5. So immediately the two of them are having exactly the same power. Raised to the power of 5, raised to the power of 5. Then you say what? Equate base. And what are the base? 2 and s. So 2 is equals to s. And it also means that s is equals to 2. So that is that for example 4. Okay, let's take one more example. Example 5. Example 5 says log 0.001 base 10 is equals to what? X. Okay, so this one is a different one now. You can see that the x now, the unknown, is appearing as the answer. Okay, it's not the logarithm itself and it's not the base. Remember example 1 and 2, the unknown was appearing as the logarithm. Example 3 and 4, the unknown was appearing as the base. But in this example 5, the unknown is appearing as the answer. So like I said, wherever the unknown is appearing, you follow the same method. And the same method is what? This is 0.001 will be equal to this base, which is what? 10 raised to the power of what? X. Yes. 0.001 equals to 10 raised to the power of x. Remember, it is this x we are looking for. Okay, so how do we solve this? Now you remember what we call standard form. You change this to standard form, and if you are changing it, remember when you are moving your decimal point to the right hand side, your power is negative. But when you are moving to the left hand side, your power is positive. That is just class work. Okay, so now we are moving this way. We move 1, 2, 3. So we move that many times? 3 times. So we'll be having 10 raised to the power of minus 3. I remember I said when you are moving your decimal point to the right hand side, your power will be what? Negative. But when you are moving to the left hand side, it is what? Positive. So we move to the right hand side. That is why we are having negative 3. So that will give us equal to what? 10 raised to the power of what? X. I believe we are together. Okay. So This, we are moving this now 3 times. That's why we're having 3. Now from here, you find out that the two base are the same. We're having 10 here as the base. We're also having 10 here as the base. So if the two base are the same, all you need to do is say equate power. Because it is the power, that is where the unknown that we are looking for is appearing. Is appearing as the power in this time. So this base is 10, this base is 10, the two of them are 10, 10. So you say equate power. So if we are to equate power, what are the powers? We have minus 3 and x. So you say minus 3 is equal to what? X. Or x is equal to minus 3. The same thing. So once the two bases are the same, you equate power. If the two powers are the same, you equate base. It works in the two ways. Wherever the unknown is, if the unknown is the base, then you have to make the powers the same and equate base. But if the unknown is appearing as the power, then you have to make the base the same to equate power. Okay, so this is our example 5. All right, let's go through it one more time. Now this is a decimal number, okay? It said log 0.001 equals to what? X. This is a decimal number, so you have to write the standard form of this, okay? And how do you do that? You move your decimal point till you get a number, a significant number, and that number is what? This one here. So you move your decimal point 1, 2, 3 till you meet a positive number or a significant number, which is this one, then you stop moving. That is why we got this minus 3, because we moved 3 times. 1, 2, 3. That's how we had this 10 raised to the power of what? Minus 3 equals to what? This 10, which is the base, raised to the power of this x, which is the answer. And I said, if the two bases are the same, we equate power. We have 10 here, we have 10 here. Okay, so what we did, we equated our power, which is minus 3 and x. And minus 3 is equals to s. If minus 3 is equals to s, then s is equals to minus 3. So that's that for example 5. Okay, so this is the end of our example 5. So let's look at, we have been talking about indices and logarithm. We have done examples on indices. We have done equation involving indices. We have also done examples on logarithm. And today we did a equation involving logarithm. So let's look at the difference between indices and logarithm. They have some differences and also similarities. So let's check out the difference between indices and logarithm, so that when you see logarithm, you should be able to identify it. When you see indices, you should also be able to identify it. Okay, let's say relationship between indices. Relationship between indices and logarithm. Okay. All right, so let's draw a table. So this is for logarithm and this indices. Okay. All right, so now when you have a logarithm equation, how do you convert it to indices? Let's say we have log 1000 base 10 is equals to 3. Just like what we solved now, if you are asked to convert this logarithm to indices, it is simply, what is the base here? The base is what? 10. So for you to get this 1000, it is simply 10 raised to the power of 3. That is how to write it in indices. So logarithm of 1000 base 10 equals to 3. In index form, you write it as what? 1000 is equals to 10, which is the base, raised to the power of 3. 10 raised to the power of 3. And you agree with me that if you multiply 10 into 3 places, you have 1000. So that's the relationship between logarithm and indices. The logarithm of a number to its base equals to an answer. That is what, when you use the base to raise to the power of the answer, that will give you the logarithm in indices form. Okay, so what happened here is a very simple thing. This is 1000, this is 1000. Then for you to get the answer, it is the base raised to the power of 3, which is this. And if you multiply this, of course, you get back 1000. Okay, now what if we have log 216 base 6 is equals to 3? How do you write it in index form? The same thing happened like what we did here. It will be 216 equal to 6 raised to the power of 3. Say 216 equals to what? 6, which is the base, raised to the power of what? 3, which is the answer. And if you multiply this, you get this. If you multiply 6 into 3 places, you get 216. Okay, let's take another one. Let's say we have log 81 base 3 is equals to what? 4. Log 81 base 3 is equals to 4. How do you write it in index form? It will be 81 will be equal to 3 raised to the power of 4. 81 equal to 3 raised to the power of 4. The logarithm equal to the base raised to the power of the answer. So this will give us 81 is equals to what? 3 raised to the power of what? 4. So you can see it. This is how it is being written in logarithm. This is how it is being written in index form. Okay, let's take another one. We have log 8 base 2 is equals to 3. Log 8 base 2 is equals to 3. How do you write it in index form? 8 will be equals to 2, which is the base, raised to the power of 3. 8 is equals to 2 raised to the power of 3. If you multiply all these things, you will get these answers back. 2 raised to the power of 3 means 2 times 2 times 2, and that will give us what? 8. Okay, let's take another one. We have log 125 base 5 is equals to 3. Log 125 base 5 is equals to 3. To write it in index form, it will be 125 equal to 5 raised to the power of 3. So that will give us 125 equals to 5 raised to the power of 3. Of course, if you multiply 5 into 3 places, you get 125. Okay, let's take another one. So we have log 49 base 7 is equal to 2. Log 49 base 7 equal to 2. It simply means that 49 is equals to 7 raised to the power of 2. 49 is equals to 7 raised to the power of 2. Of course, 7 times 7 will give us 49. Okay, let's take another one. Log 64 base 2 is equal to 6. Log 64 base 2 is equal to 6. Okay, so this is the same thing as 64 is equals to 2 raised to the power of what? 6. 64 equals to the base, which is 2, raised to the power of the answer, which is 6. Okay, so let's take the last one. The last one says log 1 over 27 base 3 is equals to what? Minus 3. Log 1 over 27 base 3 is equals to minus 3. Okay, so how do you write it in index form? It will be 1 over 27 is equals to what? 3, which is our base, raised to the power of what? Minus 3, which is the answer. Okay, so if you calculate this, you will get back this, because this is what we call inverse law in indices. When a number is raised to the power of a negative number, it means the inverse of that number. So this 3 raised to the power of minus 3 simply means 1 over 3 raised to the power of 3. This inverse has turned, this minus has turned to inverse, which is 1 over. And 3 raised to the power of 3 will give us what? 3 times 3 times 3, which will give us what? 27. So that's 1 over 27, and that's exactly what we have here. Okay, so this is the relationship between indices and logarithm. Now, let's just go through them one more time. Now, if you are given this thing in index form, you can as well convert it to logarithm. If you are giving it in logarithm, you can as well convert it to what? Indices. Now, if you have log 1000 base 10 equals to 3, in indices, it is written as 1000 is equals to the base raised to the power of the answer. That is the procedure we followed when we were solving equation involving logarithm. The logarithm itself will be equal to the base raised to the power of the answer. That's what we followed in all of this, if you check it very well. Okay, so if log 1000 base 10 is equals to 3, then 1000 will be equals to 10 raised to the power of 3, and that's what we have here. Number 2 is log 216 base 6 is equals to 3. So the answer for index form, it will be what? 216 will be equals to the base, which is 6 raised to the power of 3, which is the answer. And that's what we have there. Then the one of log 81 base 3 equals to 4, it means that 81 will be equals to 3 raised to the power of 4. Log 8 base 2 equals to 3 is what? 8 will be equals to 2 raised to the power of 3. Log 125 base 5 equals to 3. It simply means that 125 is equals to what? 5, which is the base raised to the power of 3. And that's what we are seeing here. And we have log 49 base 7 is equals to 2. In index form, 49 is equals to the base, which is 7 raised to the power of 2, which is the answer, 7 raised to the power of 2. And we have 64 base 2 equals to 6. It means 64 is equals to 2 raised to the power of 6. That's what we have here. And lastly, log 1 over 27 base 3 is equals to minus 3. To write it in index form, it will be what? 1 over 27 will be equals to this 3, which is the base, raised to the power of this minus 3, which is the answer. Of course, if you calculate all those things, you will get these answers. So this is the relationship between indices and logarithm. Okay, so anytime you are given any logarithm equation and you are asked to write it in index form, you should be able to do that. Just know that the logarithm itself will be equals to the base raised to the power of the answer. That is the procedure in all of them. All right, so we stop for today. We stop here for today. So let's take a assignment under equation involving indices. Okay, so let's take assignment for today's class under logarithm involving equation or equation involving logarithm. Okay, assignment. Say calculate for the unknown in the following question. Okay, so we have question 1 says, if we have log x base 2 is equals to 3, log x base 2 is equals to 3. So remember, you're going to look for the value of what? X in this particular one. Okay, we have question 2. Question 2 says log 25 base x is equals to 2. Log 25 base x is equals to 2. And lastly, question 3 says log 0.00001 base 10 is equals to x. All right, so these 3 questions, is exactly what we did today. Okay, this question 1 is concerning example 1 and example 2. This question 2 is concerning example 3 and example 4, and this question 3 is concerning example 5. So you should be able to solve all of them. Okay, you can see that this question 1, it is the logarithm that is appearing as the unknown. This question 2, the logarithm, the unknown is appearing as the base. And this last one, the unknown is appearing as the answer. So it's a different thing entirely. But just like what I said, in each of them, you follow the same procedure without minding wherever the unknown is appearing. Okay, so you solve this assignment and drop your answer in the comment section. All right, so this is the end of today's class. Thanks for watching. See you in our next video. Bye.